Hello, geometry students. Welcome to lesson 10.3 on chords. You're going to see that this is very much a geometry lesson, right? I should say geometry EE lesson, because you're going to see some proofs in here, right? There's some ideas. So buckle up, right? But chords. Chords is what we're talking about in this section. Oh, example 1. It says relate central angles in chords. A chord is a segment whose endpoints are on the circle. So this is your definition of a chord. One of the most special chords is a diameter, right? So remember that a diameter is a special chord. Special chord. Okay, but there's other chords, obviously. So the question is, why is segment RS congruent to segment UT? So if we take a look here, we're looking to see why is segment RS congruent to UT. Well, I see these two triangles. I wonder if we could prove these two triangles congruent. Well, I think we can, right? If we look at this picture, right, this, and this, those four segments are all radii, and all radii are congruent. And then these two angles are vertical angles, the central angles. They're going to be congruent by the vertical angles theorem. And now look what I have, side, angle, side. These two triangles are congruent by side, angle, side. So then these sides will be congruent by CP, CTC. So we just did it. So triangle QRS is congruent to triangle, and just to get the correspondence, they have R and U corresponding. So QUT, and that's going to be by side, angle, side. And again, we have four radii. And we have vertical angles. So then because those triangles are congruent, yes, segment RS is congruent to segment UT, and that's by CP, CTC. Corresponding parts of congruent triangles are congruent. So like I said, very geometry EE, right? Proofs. Not a formal proof, but still proof. Okay, so here's the introduction of that theorem. So if two chords in a circle or in congruent circles are congruent, then the central angles are congruent, right? So this is that theorem and backwards, right? So if we know that these two chords are congruent, then we know that these two angles are congruent, and vice versa, right? Works the other way around too. All right, cool. Another theorem sort of related to this, right? If two arcs in a circle or in congruent circles are congruent, then their chords are congruent. So if we know that these two arcs are congruent, then we know that these two chords are congruent, and vice versa, right? Congruent, and the idea is the following, right? I think, are we going to prove this one? Yeah, we're going to prove it in the next, so I won't give it away, right? But it's a simple idea to prove. Okay, so let's get after it right here. So it says, write a proof of theorem 10.4, which states that if two arcs in a circle are incongruent, or in congruent circles are congruent, then the chords are congruent, right? So to do this proof, and we're going to do what's called a paragraph proof. So a paragraph proof is where you kind of just write it in words, right? I'm going to create two triangles, and watch how I do it. I'm going to draw segments from P to A and P to B, and from P to C, and from P to D. And I hope that you can see that this problem is just like the very first slide we did today. So I am given, so if given arc AB is congruent to arc CD, then I know that the measure of arc AB equals the measure of arc CD, right? Definition congruent by the definition of congruence by the definition of congruence, right? If two things are congruent, then their measures are equal, right? So these are the arcs, right? Sorry if my arc's not archy enough for you. Arcs. Okay, so now since central angles, measures equal, I got apostrophe driven today, equal intercepted arc's measures. And again, I probably should have said if the measure of the central angle is equal to the measure of the arc, right, intercepted arc. So since that's true, we know the measure of angle APB is equal to the measure of angle CPD. By definition of congruence, again, just shorthanding definition. By definition of congruence, that means that angle APB is congruent to angle CPD. And there's a pair of angles, right? That's a pair of angles in our two triangles. Now I was going to go ahead and prove the triangle is congruent, but we don't need to. Sorry about that. So I was misleading. So now we're actually going to use a previous theorem, right? So now, since we know that the angles are congruent, then we know that the chords are congruent, because we talked about that in theorem. Let me look back. That was theorem 10.3, and it's actually the converse. If we know the angles are congruent, we know the chords are congruent. So by converse to theorem 10.3, I don't know, I put it in parentheses. Congruent central angles have congruent chords. I'll put that in parentheses. Congruent central angles lead to congruent chords. We know, or we can prove, chord AB or segment AB is congruent to chord CD. So again, I suppose I drew the radii in to create the central angles, right? But once we proved, so we were given that these arcs were congruent, so then we were able to prove the angles, the central angles were congruent, right? So then, because of that in theorem 10.3, the converse, we were able to prove the chords congruent. Okay, I'm going to stop there and make the next video.